Today is Thursday, April the 8th, and what we want to present here is an alternate solution to the 6100 board, which is a three-phase, 6-pulse rectifier. Instead of using a 12-pulse, 6-phase rectifier. The advantages will be that the ripple, the DC output ripple, will be smaller. Therefore, the need for an LC filter to filter out that voltage, it's less. The components are less if a filter is needed, and there's also a significant reduction of the fifth and seventh harmonics that usually consume more energy from the utility. On this particular case, we're going to just show a standard setup where we bring in the 480. The 480, one of the things that are needed, one of the hardware, the pieces of hardware that is needed, is a transformer. We bring in 480, and we have a delta Y transformer on the secondary. So we bring in 480, and we split that into a delta secondary and a Y secondary, and that's where we get our 6 phases, 3 that are shifted 30 degrees from the other one, and that powers this 6-phase rectifier. We have 2 set of bridges. Instead of having just one bridge, we have the Y bridge and we have the X bridge, and we sum up the load, and we go to our rectifying load. So we're gonna prove how this works. Gonna turn our board, apply power, just like on the other case. If we don't bring in the 3-phase, now in this particular case it will be the 6 phases, we have a phase loss. So let's go ahead and do that. Now this particular case, when we bring in the phases, the board is enabled, and that's because we allow it to be enabled. We can, if you want to inhibit them, so there it is. Otherwise we could have it inhibited. This is just with a push of a button. And then for illustration purposes, we're going to show SIG HI, which is not 4020. This is a 0 to 6, and we're going to start increasing our output or SIG HI so that we can see now the output. Keeping in mind that we have approximately 270 volts on the secondary. Now here we can see that per every cycle, here's the 360 cycles, you want to reduce that only to about 4 volts. Now we don't have only 6. We will get only 6 SCRs with a 6100 board. Here we have twice as many. Here we have the first 6, and here we have the second 12. So now we can see that when the output is, go ahead and give it the maximum, Tony. Or output is 280 volts. We can see that there's hardly, peak to peak, only 26 volts as opposed to the other one. So here this is more of a linear constant output, keeping in mind that we were using 480, not 360. Therefore the delay angle it's minimal. Under this particular conditions, 60 Hertz, we have only 7 degrees phase shift between our reference and the firing of the 8 plus SCR. We have 279 for our input, and again, very little ripple. So this is yet another possibility. Again, the only thing that it's required is a delta Y secondary transformer. This is the end of this video.